This video will go over a snack in the middle, at least questions 1 and 2. The second part will be for another day, going over parts 3 and 4. So in this task, a snack in the middle, Maddie and Clyde were pruning some trees. They were pruning trees in an orchard that is arranged in a grid. How convenient. Each tree is identified by its coordinate location. Even more convenient, every afternoon they choose 2 trees that needed to be pruned the most, and each of them works on one of those 2 trees. Pruning makes Maddie and Clyde hungry. They decide to set up a snack table at the midpoint of the segment connecting the 2 trees they're working on. If there happens to be a tree at that exact point, they will set up a table right next to the tree. Okay. So that's where the problem title comes from, a snack in the middle. They're both really lazy, so they want to put it exactly in the middle between them two. Suppose Maddie is working on a tree at these coordinates, 24 and 6, and Clyde is working on a tree at 30 and 14. What are the coordinates of the point where they should set up the snack table? Prove your choice is really equidistant from this much. Okay. So down here in this sheet, I've copied it down. I'm going to start drawing some axes so that I can use my graph to help me solve this problem. I know that I have to go all the way up to 30, which will be here. 30, 29, 29, 28, 27, 26, 25, 24, 23, 22, 21, 23, 22, 21, 20, 19, 18, 17, 16, oh gosh, I'll move this out of the way, clip, move this thing out of the way, copy, delete, put this thing way down here. Alright, back to labeling. 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Alright, so there's part of it. This is my y-axis over here. And now we'll go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can stop pretty quickly for this one. Oh shoot, I messed up. Darn it. I mixed up my x's and y's. Ooh, okay, so here's something a little weird. Let me see if I can work some magic to rotate this, to erase things. Okay. And then let's try to take this, rotate it. Yeah, that's weird. We'll have to deal. And then put it right along the grid lines. Like that. Okay. So now it goes the wrong way. Okay. Undo. Let's rotate it. Gosh. Which way? Okay. Our x is going to go the wrong direction, but it'll still illustrate the point. Alright. So, this is now the x, this is the y. Sorry, it should scroll the other way, but the same idea will work. So, 30, oops, looks like we need a bit more for the y. 11, 12, 13, 14, 15. So, let's see, Clyde is at 24, 24, 6. 6 is right here, 24 is here, this one is Clyde, 24, 6. And then, no, that's Maggie, here, Maddie, oh, all kinds of mistakes. Maddie. Clyde is at 30, 14. And then 14, 30. Here is Maddie. Shoot, Clyde. Alright, I'm saying all the wrong things, but at least I'm labeling it correctly now. Here's Clyde. 30, like that. So, using the best possible tracing I can, here's one leg of our triangle. Here's another leg of our triangle. And we are looking for this blue distance in between. If I drew it absolutely correctly, we should find halfway, maybe 1, 2, 3, 4-ish. Maybe this point right here. So visually, that looks like the midpoint. Midpoint, it's halfway in between. And that's approximately 9, 28, 27 for the x. 27, comma 11. No, 10. Let's see if that's about right. 27, comma 10. Let's see if we can confirm that any more ways. That's using our graph. If we grab some other colors, I'm going to add in, maybe in brown, we have this right triangle over here, from that midpoint downwards. So, we have a square in brown over here. We have another square in brown over here. That's 4 over. And then we notice it forms another square like so. So looking at just the brown, right, there's 3 squared, that's 9, plus 4 squared, 16, gets us to x squared. 9 plus 16 gets us to 25. So x is the square root of 25, which equals 5. Okay, so far so good. So we're working on confirming whether or not this thing is actually in the middle. If we draw this right triangle over here, now in gray, we have yet again a square that is 3 by 3 over here. Here's another 2, 3, 2, 3. And going this way, so let's see if that actually is 3. As I'm looking at this, that's in the middle. 3. This way should have been 4. Looks like I messed up one coordinate. Maddie should be, let's see, 11, 12, 10, 9, 8, 7. Yeah, I messed up in the beginning. Maddie's thingy should be actually down over here. And then the triangle should look like this. So this one should be longer. It's off by 1. It's like, wait a second, I should see that it's in the middle. It should be 5. So then this half, okay, we get another 3 squared, so that's 9. Over here is 4, 16. 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. So x has to equal the square root of 25, which is in fact 5. Cool. using the graphs, had I originally plotted everything correctly, with Maddie being here and Clyde being here, we see that this point, that I'll redraw in blue, is in fact in the middle. So using our graph, we saw that its coordinates were 27, 10, and looks like we confirmed, because both ways, like from the blue dot to Clyde and the blue dot to Maddie, it has a distance of 5. For the second problem, we're going to try to do that again for a different set of points. These ones are a little bit smaller, so they're a little easier to map out. And these first two parts is using numbers, using the graph, and hopefully in the second part of the video we'll have a generalized pattern or a formula for the midpoint after we do some more practice, right? We're finding the numbers and then looking for a pattern that could be represented, maybe with some variables, maybe there's some kind of trick to it. So for this problem, we have -3, I'm going to write it in for the x, there's y, I'm not going to make that mistake again, there's x and y. So we go, okay, let's have -3 be here, -2, -1, 0, 1, 2, 3, 4, 5. And then it goes up for the y. Okay, so I'm gonna move that down a bit, maybe over here. And then moving upwards, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That should be enough space. -3, 4. Okay, they're working at different places. There's one person at -3, 4. Here's another person at 5, 12. 5, 12. And again, we're trying to find the middle of all these people. So we'll use some colors to outline our right triangle going up this way. That's our change in y. We're going to need that. And going left and right, maybe in green this time, going this way. So our change in x. We're trying to find this distance in blue. Looks like the middle will be 4, 1, 2, 3, 4. Maybe this. Maybe here? Nah. Let's see, where's middle? 1, 2, 3, 4. Here, here. Oh, this one's gonna be harder to tell. Is that the midpoint? 8. 1, 2, 3, 4. I wish I drew this more exact. 1, 2, 3, 4. 2, 3, 4. 4. Maybe my thing curves it a bit more. It should be this point right here in blue. So that's 1, 7. That seems a little off. Let me try drawing it again, being more precise. 5, 12, -3, 4. Yep. So one more time, drawing the hypotenuse of my right triangle. Maybe I'll use my phone. So I have a straight edge on my tablet. Now I draw this in. That looks more precise. Yep. That looks better. 1, 8 should be our midpoint. So there's another lesson in precision. I should just use a straight edge from the very beginning. Let's see, purple. I'm going to show that this triangle is in fact half, and then this one over here is going to be half. Like that. Maybe I'll use a different color. Let's use brown. This one. we should show that these distances, the one in brown here and the one soon to be shown in purple, are the same distance. That's what it means by equidistant. So in purple, we count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Get this one. 16, 16. So this box is 32, which means this square root here is square root 32. And see if we have a similar luck with what's in brown. Going this way, we notice we have yet again a box of 16. Over here, another box of 16, which means this area of this box is 32, which means the square root here is the square root of 32. Nice. Because they're equidistant, root 32 equals root 32, these coordinates 1, 8 is in fact the midpoint. And that ends part 1 of the videos for the snack in the middle.